All right. Welcome, Antonio Agus.
Hey,
Hey, how's it going?
Nice to see you both. All right, so let's talk about the agent panel. So let's start from the beginning. So why introduce an agent panel to Zed? Because we already had this other assistant panel. Like, what was the purpose of introducing an agent panel in the first place?
yeah, I think there are a couple of reasons. The first reason is that um, I think the previous experience. So in Zed, we used to have this thing called well internally we called Assistant One, which was this essentially very one-to-one representation of the interaction with the LLM, where like you had an editor and you could literally see like the back and forth between you and the response of the LLM. And we've received tons of feedback about that, where it was great for certain use cases, namely if the conversation was mostly append only and write oriented, like people would love it. But on the other hand, the fact that it was an editor, we always see feedback I cannot distinguish between like the agent response and like my message. Like, why does this not look like a chat? Like, why is this like this different use case? And so one reason was, it would be nice to experiment with like a more read friendly version of that experience. That was one thing. The other thing was like just the introduction of tools and like agents in general, right? Like this realization that like, oh, what's an agent? It's like, this loop, right, where like the agents wants to call tools, and like you give the result of those tools to the agent, and like just having like a more sort of I don't know, less editor oriented and more like, UI around, like more Chrome around that interaction felt compelling. And I think there was also like a technical reason for it, which was, I think like there is a world, and I'm actually excited to explore that in the future, where like we bridge these two UXs, but the editor based version, what we call the System One, like basically in order to add any feature, like many times we had to like dive into the editor itself, and that's kind of like a pretty complex primitive to like change and like add support. If you want to add feature support to that, it's doable, and I'm pretty proud of like the structure of that system. But it's not as simple as adding a div here and another div there, right? And so like just even being able to experiment more quickly, right? I think that was also like what went into it. Also, like, I don't know, another thing that's interesting is like, I think one of the hypotheses we had was that, in the System One, I think you could see, like I said, like a one-to-one representation of the conversation with the LLM. Whereas like with agents, I think oftentimes the context is kind of manipulated under the hood for you in a number of ways. Now, in the latest version of Zed, like we tried to like not change context around and like add things, like change the prefix too much, because that's not super cache efficient. But it is true that like we sort of send messages to the agent that are like, hey, I don't know, that we don't really want the user to see, right? Like, hey, here's this is the list of files that have changed since last time you responded to me, right? I guess
Right.
probably, but yeah, you know more about that than I do. So yeah, this is like, I don't know, these 4 or 5 things I think went into the, oh, actually, we should experiment with this different UX. Yeah.
Yeah, let's talk about context for a second, because there's a couple of different aspects of that. Like, I remember one of the earliest projects I worked on when I joined Zed was this idea of what we were calling context inference. So in the assistant one, you had these slash commands, and you could
Mm-hmm.
do like slash file, and that would mean like import. It was basically like copy paste the entire file
Right.
into the assistant, into the conversation, to give it as context. And the thing that I was working on was called slash auto, and slash auto's job was to basically go and like figure out what context to put in there based on the prompt that you'd put in there.
Right.
Um, but in retrospect, it's like that was sort of like we were trying to solve this problem of like, how do you get the context into the agent
Right.
using like, really, it's like, yeah, what if you just always want automatic context inference? In other words, like, what if you want the agent to just go out and be able to discover its own context? And a really classic example of this was, we have this one giant file called editor.rs. It's like 10,000 lines of Rust code. I've now seen, I was looking at the Zig code base. Andrew Kelly was showing me this, and it's like, there's one file in there that I want to say is 200,000 lines of code.
Nice.
So, so yeah, you really just cannot just put that all into the context window. And even if
Nice.
you do, there's going to be very serious downsides, right? So even when you had slash file, like forget about slash auto. If you just tried to put slash file and you're like, hey, as context, this
Right.
is the file I'm working on, and it happened to be that file, you're already toast. It would just say like, oh yeah, there's no like the game over, right? You've exceeded the model's context window. So um, yeah, so getting the agent to be able to understand context by figuring out itself was tricky. Like one of the things that I worked on was making it so that if it gets a larger file like editor.rs, we just send it the outline as context. So it's like, oh, here are the functions in this file. Here are the, like the different structural elements and then line numbers, but not showing it every single function body. And then August, I know one of the things that you worked on was getting that context to stay up to date as like the user makes edits, like interspersed with the agent making changes. Do you want to talk about that for a sec?
Yeah, so basically, I think we created this whole system where we track buffers. So when the model is gonna, well, whether the user adds a file as context or the model uses a tool to read a file or it makes an edit, we track which version of the file it read, and then as we later make more requests to the model, we're gonna check have have are the files that the model have read at the same version it knows about, so that if it's different, we attach a notification basically at the bottom of the request that says these files have changed. Now we could probably improve this a little bit later. So far we just tell it this number of files have changed. I think maybe in the future we could say, okay, send a diff to it or something like that.
Yeah,
But we haven't eval that yet, so yeah, we haven't got to that. But seems to be working pretty well in this with this mechanism. Because then it's up to the model. Like I also experimented with just like updating the results in the previous conversation, right? So like it
yeah,
will go back and change the contents of the file, but that's not amenable to caching.
right,
Um, and yeah, I think this is working pretty well because then it's up to the model to decide when it needs to reread the files. Maybe it doesn't care, right? Because it's not going to touch that file again.
right.
Um, so yeah.
And all that is stuff that you used to have to do manually in Assistant One. It's like if you went through and the model was telling you new things and you copy paste them in, it would still, but as far as it knew, like the old version of the world was still the same. If you made an edit to a file, it had no idea that happened.
Right.
Um, Also, just basic stuff like it couldn't follow imports. So if you just gave it a file, but there was some important code that was in an import that it couldn't see, oftentimes it would just hallucinate like what it thought that function
Mhm.
was because we didn't give it the ability to go figure it out for itself. So all these things put together, it really made it a lot less tedious and time consuming to get the model the context it needed.
Yeah, I mean, and like the reality is that Assistant One was created when agents were not like there was just like you ask a question and you get a response. Period. And
Right.
even like when we had tool calling, like it wasn't in a loop. Like the agent wasn't able to kind of like keep going. So yeah, very different eras, I would say, right? And
Yeah.
I think yeah, that's why we were working on auto, right? It was like, oh, wouldn't it be great if like the model could like fetch the context?
Yeah.
Well, I guess that's an agent, right? That's the definition of like a agentic
Yeah. I mean, the
model,
approach that I was trying was more I wouldn't call it agentic just because it was basically
right?
around like pre-indexing and summarizing your
Right.
files. But yeah, I mean I think maybe a good way to summarize the like sort of eras is it's like you start off with the Chat GPT style where it's like you just have a web interface and it's just a conversation, and if you want anything from your code base to get in there, you have to copy paste it from your editor into Chat GPT. Then the next era is what we are calling Assistant One, where it's like, well, what if instead you just had that chat interface directly in your editor, and we could save you some copy pasting by making it so you can just
Right.
sort of copy paste in fewer keystrokes, basically, just like slash file and this and that. But fundamentally, it's still just a conversation. And then now we're into this new era where, again, it's really just behind the scenes. I mean, as we all know from working on the code, it is still just a conversation. It's just that now there's like special markers in the conversation where it comes back and says, hey, I want to follow that import and tell me what's in that file. And then we don't make you do copy pasting or slash commands or anything. We just
Mhm.
do that and give the model the answer, and then it can just keep
Yeah.
going back and forth.
And I
You know,
still think like yeah, there are use cases for both. Like I still find myself using we're referring to it as assistant one. In the UI, it's actually called text threads. That's the name of the feature. So you can still create text threads in Zed. And whenever I write something, some prose, I prefer that version because I want the AI to go, to I want to have a conversation with the AI, but I don't even want to think about tools. And there's a way in the new agent to kind of disable all the tools, but like there's something nice about just having like a stripped down version where like I know exactly what's going in, and I can just manipulate the context myself. So and that's where I was excited. What I was saying, I was excited. Like I think there's a future in which like we bridge both versions, where like we can add context, wherever we want, but like we can hide it if you don't want to see it, and then you can drill in, as needed. We're gonna work on that, I think, but yeah.
for sure. Yeah, it doesn't. It seems like intuitively there don't need to be two UIs. The main reason we did was just that, like you said, a lot of people liked the original interface, and then even when we released the new one, there was still some percentage of people who said I prefer the old way, and we didn't want to take that away. So it's ideally we can arrive in a world where like everybody's there's one interface, but it meets everyone's needs.
Hmm.
Another use case that I've seen for text threads is for creating the initial plan. So what you do is you create a text thread, and you talk to the LLM about how it would go about implementing something. And then since it is a text thread, you can edit it. So if it came up with a almost like 90% good plan, but you want to make a change last minute, you could just go and do it. And then you use that text thread as context for a normal thread. And now you just started, so now you run the agent. Ideally,
Right.
obviously that's even more smooth than that, but that's a use case I've seen people you do.
Yeah, and I'm sure we'll get into this later when we talk about like, potential future directions, but like there is this kind of idea of like a more formal like orchestration kind of UI where like you want to have a more organized way of dealing with like multiple agents and things like that. But okay, so that's context. That was sort of the first piece, was like getting enough context into the LLM, and then also like dealing with edge cases like, okay, what happens if it's like the file is too big, you don't want to put the whole thing in there, or what if the file changed, you want to automatically update it. So let's say that the LLM sort of got the context it needs. And I guess the next piece was, now we don't want to just make it be this sort of read interface where we're just putting information in, but also we want to let the LLM write code. So in the old way, right? Original chat GPT, copy paste from the website, assistant one, you're still copy pasting from there, or like you maybe have a keyboard shortcut that'll like, insert it directly into your current buffer at wherever your cursor is. But again, that's just kind of a convenience around copy paste. But of course, with the agent panel, we have much more sophisticated options. So let's sort of start off talking about just like the really easy one is like create a new file. Or just like you have a tool where it's like you start with a blank file and you just print out all the tokens that go into that file. So the first version of that tool actually was, oh, you know what? I skipped a little micro era, I guess, which was the Lua tool.
Oh yeah,
How could I
that's an
forget about
interesting
that?
one. Yeah.
Yeah. So the idea there was, at this point, we didn't have any tool calls. And the idea was essentially, okay, so if you look at like all the different tools that people are using for agentic AI editing, they've got all these different tools implemented and so forth. Well, a lot of what these tools are doing is like reading files, like open a file, close a file, make an edit to a file, this and that. Well, what can do that is just like a programming language. And what can write code? Large language models. So what if we just gave the large language model the ability to just write a program that makes the changes to your code base, and then we just execute that program? And we chose Lua because Lua has really nice sandboxing capabilities. So we could do stuff like say, okay, yes, it thinks it's able to write to anywhere on the file system, but actually we can just restrict it in Lua to just like, within your project and stuff like that. And make it so it can't like override, the Git folder or whatever. So we got that working, and if you look in our commit tree, you can still bring that up and play around with it if you want. But that had some problems. Do you guys remember what some of the problems were?
uh yeah, I think like there are a couple of things. I think one was just like I guess interpreting, I don't know, like there was like this latency, right, between
Yeah.
like actually performing the act, like before performing an action you had to produce code to perform an action, and so there was
Yep.
this like extra lead time to kind of actually doing work. um I think like the highest order bit there was just like at some point the agent got so good at just calling tools that it was just like, I don't know, let's just use the thing that these things have been trained on. Maybe there were other reasons though, and yeah, I'm blanking on.
Yeah, I mean, like, well, so something I'm sure we're going to talk about was is getting edits to happen. So
Oh,
I
right,
mentioned like creating a file first because creating a file is like one of the easiest,
right.
like tools to create. But yeah, this time we didn't have like multiple tools. We just had sort of one tool that we would give the model, which is like, hey, you can write a Lua script. I remember a couple of different failure modes of this. One was it would like to write helper functions for itself. So instead of using Lua's like file open API, I'd be like, oh, let me just start off by writing a little helper function that's like 30 lines of code long that just like takes a string and opens the file and doesn't have to use Lua's like built-in. Like, okay, and then it would call it once, right?
Right.
So like you said, like latency, right? I don't want to sit here and wait for that to like stream all those tokens in just to get used once total. The other thing was that, yeah, you mentioned like these models are very explicitly trained on like how to use like a variety of different simple tools, but this was a much more complicated tool, and especially because as we sort of started trying to address more and more edge cases, we had to diverge more and more from just like stock Lua out the box. We had to say
Hmm.
like, oh, by the way, this is not just a standard Lua, but also you have like a code search function. Did you know that?
Right.
Okay, it's here's the type of the function, and you can call this function and it has these arguments, and it'll give you back these answers. But a lot of the time, the Lua it would write is just like, I'll just use grep, and it would actually really like to write Lua code, which would then just like run a bash script like in a Lua ticket, right? It was like literally like I'd be like, you have this nice project search function in Lua. I've made it available to you. Just call it. And then it would write out a script that's like helper function for opening a file, followed by execute bash calling grep, right? It's like, oh no, come
Yeah.
on.
I
And so that's
still,
where we kind of
yeah.
yeah, we're like, okay, what if we just give it a tool called project search and like it's trained on how to use tools and take the tool description and decide whether or not to use that thing or not.
Yeah,
Um,
even though we ended up not using it yet, I still think it was a cool idea, a clever idea. So,
Yeah, I mean, one of the things that does seem still kind of promising there, which might be a reason to try bringing it back, was one of my hopes for it was that there would be some category of problems. And granted, these might not be a super common case, but something where the model's like, you know what I really want to do is I want to do the same exact operation like 20 times with
right,
slight variations.
Right.
It's like, wouldn't it be great if you could give the model the ability to write a for loop? And
yeah,
it
and
can.
also
It knows how to do
this
that.
idea of like, because I think right now tools are like, you call it, the model calls a tool, but like in programming languages, you have function composition. I mean, this idea of
Right.
like exploiting that, I don't know, there's still something there, I think, but yeah,
Yeah, I agree, and I think there's more room to explore and like kind of revisit that. But at some point, we were just sort of like, okay, like this experience, like it did work. I mean, in the sense that like it would make edits. Sometimes it would mess them up. It did make was able to create files and delete files and do searches and stuff like that. It didn't feel great though. It didn't feel like, okay,
mm,
this is like the best version of this experience. So we kind of were like, okay, let's try just giving it a totally normal set of like small simple tools that are just all hand wired to be like, you have project search, you can write a file, you can edit a file, you can delete a file. Those all in the for the most part worked much better right out the box. There was one particular tool though, and you guys know exactly where I'm going with this, that was just way harder to get working than all the others, but also it's a really important one, which is just making an edit to an existing file. So this is like not making the whole file from scratch. And granted, you could tell the model like, oh, just like delete this file and then recreate the whole thing. But that's really slow, especially like imagine doing that for editor.rs, like 10,000
right.
lines. It's not what you want. What you want is to be able to give the model the ability to say, okay, just make this one little change in here. And it sounds so easy when you say it like that. But yeah, I know, August, you worked on that a lot actually. I don't know if you have any memories from trying to get that one working.
Yeah, I mean, we tried a lot of different options. I think the first thing we tried was like either style search and replace blocks, which actually is not that different with from what we ended up with. So basically, this is a setup where you have your main model that drives the conversation, right? And then at some point it performs an edit tool call, and it includes a path to a file and instructions on how to edit it. And then what you do is you reach out to a second editor model that you can make separately configurable, um, which gets fed the conversation, the instructions, and it's asked to produce these search and replace blocks. So yeah, I remember we wrote like a whole streaming parser for it, and then started applying the edits and all of that. I think the main reason we abandoned that approach initially was that we didn't really have a nice eval setup at that point. So we didn't really have a good way to iterate on it, and we didn't have a good grasp on what were the failure modes. So we saw that was kind of unreliable because of a bunch of reasons, and then we decided to look at what other alternatives were using, and we saw that I don't remember which agents, but they were doing like asking the main model to produce the search and replace blocks, which is what we used for a long time, for
Mhm.
quite a bit in the development. Um,
Yeah, I think the premise was because I think Claude has like this computer use API, right? Where
right.
like they literally, train the model to kind of support old string, new string. I forget exactly what the API is, but like that search and replace idea. So like, here's a string I want you to search in this buffer, and I want you to replace this string with this other string. So that's kind of the definition of the tool. And so I think at the time we were just like, okay, if these models have been trained to on this exact use case, then let's just go with it. I guess though, yeah, like I think that worked for a while, right? Although I think, yeah, we went back to actually like a streaming sort of edit world because I think there's a couple of reasons. Like the first is like maybe this is the only reason really is the latency of invoking tools for Claude. Like Claude doesn't support streaming tool calls. Like it doesn't let you like you have to wait for a whole field to be streamed in before parsing it, which
Right. So
means
it's
that
like,
go
yeah.
ahead. Yeah.
Yeah, I was just gonna say like the JSON, right? It's like, yes, they support streaming JSON, but only one field at a time, which means if it's like, oh, I'd like to stream in an edit, and it's like, here's the title of the edit. It's like, great, okay, and then here's the string I'm searching for, great, and then right, you're just
Right.
waiting for it to say like, what's the string you're replacing it with? It's like, hang on, it's this really long one. It's gonna be a while, and you're just sitting
Right.
there watching this loading spinner. It's a really bad UX.
Right. And so like we went back to that sort of Aider style approach. Instead of using, because Aider has this like format that they came up with where like they have, I think the delimiters are like similar to like merge conflict, get merge conflict delimiters.
Mhm.
Instead, we went with like XML tags. Claude loves to output XML tags and like understands them very, very well. And so, yeah, like it's conceptually similar. So, like, we have the outer model sort of like driving the agentic loop. And then, like, we have the edit file tool, which is implemented in terms of like another call to the same model. Main reason is that like we already have like that conversation cached from the main model. So all we need to do is append, the edit piece at the end, so we can reuse most of the tokens that we already like pre-filled, computed in previous iterations of the conversation. And yeah, we asked this model, hey, okay, now given this and given these instructions, please produce edits. And like the edits are streamed in this like old text, new text format. It's essentially the same as like search and replace. But the cool thing about it is, I guess a couple of things were pretty cool about it. One is we built it in an eval driven way. So we literally started with this set of evals where like we TDD'd it with evals. Like we started with a very the one that I love to do is translate comments to Italian. I do that in all my demos, and this is an eval in the Zed repo. You can check it out, and like sort of hammering that eval until sort of we had like 100 iterations of it passing. And I guess that's a crucial thing. Like it's not enough to run these things this eval just once, because the search space is huge. These are stochastic machines. Like you don't know what you're gonna get, so you need to have like confidence interval of like how often it's gonna work. And so yeah, like some of these evals, like we run 200 times, and we have them fail if like they don't pass a certain threshold. So that was interesting. And a cool thing that we did there was like as the eval failed, we would kind of take those inputs where like the model sort of output weird stuff, and there we had two choices, like either change the prompt and rerun the eval so that like the model outputted like a better version of an answer. That was a result, or like make the parsing or whatever like deterministic part of our code we implemented like more resilient to the model outputting weird stuff. And I think there's a couple interesting things we did there that we can dive into if you want.
Yeah, totally. I think so. There's a couple of interesting things you said there. So one is about the number of iterations, right? And you dialed it all the way up to 100 before you started feeling like, okay, I'm getting pretty consistent results here, like 100 iterations of the exact
Right.
same test. It's almost feels a little bit closer to like property based testing or like fuzzing than it does, like unit tests. Even though like yeah, we're actually asserting something like pretty small and narrow like a unit test. Like in a property based test, oftentimes if you're running that many iterations, you might be asserting multiple properties at the same time. But
Right.
here it's really just like, yeah, did it like actually do the edit that I wanted?
Right.
But yeah, I mean, so it's always funny to me when you see these YouTube videos that are like, oh, I compared like, these three like, AI agentic systems and I ran them once each.
101,
And,
right?
and I'm going to draw conclusions from this. I'm like, come on, it's like you're just measuring noise and then drawing conclusions from that.
Yeah.
But
Yeah.
but that was a good point. And then another interesting point I thought was so the symptoms that you would see as a user when these things would fail is that, so number one, you would see a failed edit tool call. So it would be like, oh, the model tried to like do this edit, but it was unsuccessful. But after that started happening a couple times, the model would be like, I think this tool is just broken. Now it's not
Right.
broken.
Right. Write a bash
It's just
script
like,
for
well,
it.
yeah, you got unlucky a couple of times, unfortunately. And well, I mean, the model generated, like the most common failure mode would just be that it's trying to do a find replace, but the find text that it searches for is just not actually there because
Mhm.
it like looks for it in slightly the wrong place. Or I remember August, you worked on like trying to get it to be indentation insensitive because sometimes it would search for like, well, the tokens are right of the actual code, but like it didn't indent it the right amount or something like that, as what's actually like literally in the file. And so you would see things like this, and then you start to see the model just like try to sort of work around the broken tool. So you could always tell when things had gone off the rail when you start seeing it's like said. It's falling back on like
Right.
command line tools, or like sometimes it would like create a new file. It would like make a backup of the existing file. It would call like .bak and then be like, okay, so I got my backup. Now I'm going to create a new file and then I'm going to copy that over the old one and then diff them and see if right. It was just this whole like, it was kind of funny, but also like a bad user experience to just watch like, oh, it once again failed to apply an edit. And yeah, so one thing you mentioned was like, doing this in an eval driven way. So this is sort of the moment where we were like, okay, we're done experimenting. Like we're done with like playing around with like these different approaches. We've got the general approach. Now what we need is rigor. Because
Right.
your point earlier, August, like it's like, okay, we don't really have any confidence that like the tweaks that we're making are not breaking other things. So like how can we like iterate on this one thing that's like we know from experience trying it out is like very often failing, and we need to get it better. How do we do that? And you also mentioned, Antonio, that one of the other keys turned out to be just making like us more resilient to bad inputs from the model.
Yeah. Yeah, that's kind of, to me, that resembles a lot. You know how like browsers are often, like people often say that browsers abide Postle's law, basically like being resilient to like accepting all kinds of crazy JavaScript and just like whatever, like give me a bunch of HTML, JavaScript, and CSS, and I'm gonna render something, right? And
Right.
I think that was one of the successes of the web. I think agents are similar in that like we need to be resilient to all kinds of like crazy inputs. Like one failure mode that we saw was like that the model, despite our best efforts in prompting it and telling it you gotta output old text, tag old text and then end of old text and then new text and then end of having like well-formed XML tags. Sometimes it just doesn't care and it will output old text, spit out some text, and then end it with like this new text, which is like crazy, but
Right.
that's it's tokens to the model, right? Like it
Right.
doesn't, and to its excuse, it's also like there's like a lot of context that's like it needs to produce edits in like this see these ocean of like unrelated things, right?
Right.
And so just being resilient to that was, is one example.
I've
Um,
I've actually wondered. Now, I don't know anybody who works at these companies, or at least I mean, I guess I do, but they won't talk about these things. But like, I've always been curious about how they transition, because I remember in the days when we first started working on this stuff, like in the Assistant One days, a thing that was just sort of known is that models are very bad at producing JSON. And one of the things that changed, like you mentioned, like models got good at tool calls, was that they introduced this capability where you could give the model a schema of your JSON,
right.
and it would reliably produce at least syntactically well-formed JSON
Right.
that generally did conform to your schema. Sometimes your schema would say things like, uh, here are the tools that are available. Sometimes it would hallucinate like a tool name, but it would
Hmm.
always like fit in the JSON structure that you provided. I had this hypothesis about how they're doing that and how they got it to be so reliable, which is that I think they might just be asking the model like one prompt at a time per like JSON field. So
Interesting.
as an example of like, you just gave the old text, new text, the equivalent for us would be like, instead of saying, hey, output the format in old text, new text, you just do a different prompt for each one. You say like, okay, I'm ready for the old text. Go ahead. And it gives you the old
Right.
text and it stops. You're like, all right, great. We're done with that. Now give me the new text, right? So you get rid of
Right.
the whole XML thing. But of course, if you're doing that on their side, they can
Right.
just
They
do
don't
that
have
with the
latency.
GPU. But for
Right.
us, that's like extra round trips every single time you want to do that.
Right.
So it's a lot harder for us to do it in user space than it is for
Mhm.
them to do it on their side, just on the hardware.
100%. And I think one thing that's also interesting, I guess we didn't say like what this enables. I guess, the cool thing about streaming the old text and the new text in, right, like token by token, is that now we can, in a streaming fashion, locate the range that the model wants to replace. So like we can show that in the UI, right? Like you as a user don't have to wait until like both the old text and the new text have been streamed in before seeing what the model is trying to look at. And so yeah, you'll see in Zed, like if you, which by the way, you can also follow the agent around, right? Like if you follow the agent, you'll see the agent sort of locating a piece in the input, kind of like scanning it, and then like again in a streaming fashion, kind of start applying the a diff on that range that it located. So this was done like, I don't think it necessarily like made the reliability of the tool, of the edit tool, better. I think it did because we did other things in order to support like locating that piece of text. But crucially, it sort of like did something that is like true in every aspect of Zed, which is like we want the editor to be responsive. And so even when
Yeah.
you interact with an agent, you want to see stuff happening. Like you don't want to sit there waiting like on a spinner or something to
Exactly,
see
right.
progress.
It's like, even though we're not able to get you the final answer any faster because we're just limited on how long the model takes to come back to it, we can at least be faster in terms of like getting you portions of that than if
Mhm.
we were just doing it the naive way.
Totally. And we did employ like clever tricks to like, because sometimes the model output the old text, but like it's close to what you want to replace, but it's not quite exactly that.
Yep.
And so we implement this like modified version of fuzzy matching with the Needleman-Wunsch algorithm, where like we sort of have this matrix of like, the input buffer and the text that the model is trying to match, and we sort of try to find what's like the most likely match in the input, and as we sort of progressively make that range that we're trying to locate better, we show that in the UI. And so as a user, you'll see like, oh, it's here, oh no, it's here, just
Right.
browses around. I think that's a cool thing.
Yeah, well, and it's kind of funny because if you look at the code where it is today, you might think like, "Oh, this is wildly over-engineered. You don't need to do anything that fancy. Why don't you just do a normal find and replace?" But of course, the way that we ended up here was that we tried a bunch of other things as we've been discussing, and they just kept falling over. And so like now we ended up with this really, really error tolerant, like the input can be off by ways that we can't even predict. Not just white space, but in other ways too. And we're doing this like fancy probability matrix to try to figure out like what it meant, trying to like infer its intent. And then we're like, you can like follow it in real time, where we're doing this like workaround for the fact that like it doesn't do streaming except on a per field basis.
Mhm.
um, and like all these different things. But at the end of the day, it's like that just makes the experience like noticeably better. I mean, if you compare the current version, of course Zed's open source, so you can just go check out like 2 months ago and look at how it felt. It does feel a lot better to use because of all
Right.
this work.
Right. One thing that's I think is worth talking about also about how how far these agents have come is I think for a while in terms of editing we were thinking of like fine tuning a model to apply edits, right? Because this was
Yep.
another like avenue that people explored, other editors too, where like you sort of have again an architect model that sort of drives the agentic loop, but then when it's time to apply the edits, you just sort of shell out to like a smaller model that potentially you fine tuned on applying edits that takes sort of like the instructions and usually these instructions are written in like in pseudocode, which LLMs love to do, and they input, and so like and then you would have this like smaller model kind of like weave the those instructions into the final code. And interestingly enough, I think like agents don't need that now. Like it seems like we've reached a level of capability in terms of like editing that like doesn't really need this fine-tuned model. I don't know. I thought that was interesting. It was like a massive like time saving for us, right? Because we didn't have to fine-tune such model. So
Yeah, I mean, especially if you think about like if you're going with the find and replace thing where you're being very precise about what you want the LLM to like generate for you, then it's like, well, if I have the option of having like today Claude 4 Opus is sort of like the best coding model that we're aware of. If I want Claude 4 Opus levels of quality on my edits, then the only way to get that is to ask Claude 4 Opus, what is the exact code that you want to print out here? In contrast, if I just say, "Hey, Claude 4 Opus, just kind of describe in English like what you want done to this," and then I hand that off to a weaker model, even if that weaker model has been fine tuned on edits, I don't think it's going to give me the same quality of code that Claude 4 Opus is going to
yeah,
give me
yeah.
for that edit.
Usually, what the way this is implemented, I think, is like actually the Opus in this case would output like a piece of code and like elide pieces that are not important. So like I think the smaller model would be able to kind of get close, but agreed. Like I don't know. I think these models are good enough now that uh, you don't
And,
need that.
and that now that depends a lot on the size of the edit too, right? So like if the
Right.
edit is like I'm an editor.rs and it's like it's going to write me a new like 200 line function, right?
Right.
In the middle of that
Totally.
10,000 lines.
Totally.
Yeah. Um
Totally.
Also, it
And
would make it
oh,
harder to bring your own API key because now we have to run inference for this like model, or you have to run it yourself somewhere. So it makes it a little harder, I guess, to support that use case.
mhm.
Right, like having that as like an interesting kind of forcing function for like how many different models are interacting here is just like, yeah, you can just bring your own API key and you don't need to give us your credit card or anything. You can just use whatever. Means that yeah, it at least needs to work without calling out to a separate model that we're paying for. Um, Another interesting topic, I think, when it comes to like tool calls and things like that. So, one way that you can have the model make edits to your code base is it's just like old text, new text. Another way, though, is to use like some of the code refactoring type features that you have built in from like
Right.
language servers and things like that. So I remember working on this for a little bit, and one of the biggest challenges was actually like I have this whole and there's like you can see it in the pull request like here's complete access to all the like LSP stuff. You can do arbitrary code actions. It could even go in a little loop and say like what code actions are available here, just as if you as a user had brought up the little code actions menu on whatever code is highlighted, and then it could tell it here are the code actions that are available, and then it could come back and say I want to run this code action with these parameters, all that
Right.
stuff. It would not choose to use those things. Like it just never reached for him. Gave it all this, fancy, powerful stuff, and it's just like find, replace, find, replace, find, replace. Like that's what it's happy to do. Which on the one hand was frustrating, but on the other hand, I did find something of a solution there. But this kind of gets into like the trade-off space, which we should probably talk about a bit. One of the solutions that I found that like worked, but with obvious downsides, is like if instead of making it a separate tool, you sort of combine an existing popular tool and give it more options. So
Right.
in this example, it would be like instead of making an edit tool and like an LSP tool, you combine those two and you have like the edit tool now has like, okay, which mode of editing do you want? Do you want the find and replace mode, or do you want the LSP mode, or blah blah blah? Somehow, at least with Claude 3.7 Sonnet, which was what we were trying out then, I don't know if that's changed now, but like it really seemed like giving it a smaller number of tools, each of which has more options, made it more likely to choose those other options. So it was almost as if it's like decision hierarchy was like, okay, I want to do some editing, so I'm going to use this tool, and then separately, okay, which mode of editing do I want to choose? But obviously, doing it in that way makes things a lot more complicated, like both for us and also like for the model. And so there's a lot of trade-offs around like choosing to do something like that.
Yeah, I think like that kind of goes into the territory of like this idea of subagents. Maybe we can talk about it later, but just this idea of like, yeah, like there's this hierarchy of agents where like there's maybe an orchestrator and then like small, shorter lived agents, or maybe long lived, who knows, like where like, yeah, you can just have an agent go off in a sort of more confined scope and just do a certain task. Yeah, because like I think that's something we've seen, like even when you install lots of MCPs or like an MCP with like a ton of tools, I don't know, the model is just like, I don't know, it won't use all the tools, let's put it that way. Like it'll just stick to fewer tools than the ones that are available, and it is a challenge, like what's the right amount of tools. And that's where I think like, yeah, maybe having like these namespaced, these like, yeah, smaller agents that like can do certain tasks is an interesting research direction.
Yeah, and it's definitely like it's something that also varies by model. Like some models will use tools in like kind of a different style and like a different way than other models, and which gets tricky because like we've all at Zed, I think, primarily been using Claude 3.7 Sonnet up until Claude 4 came out.
Mhm.
Um, but there's like a subset of people who've been like trying out Gemini, and like one of the like Gemini 2.5 Pro, and one of the criticisms that people have had of Gemini, not just here but elsewhere, is just that like Gemini just like is kind of shy about using tools, is the term I've heard. It just like doesn't want to reach for tools as often. It's like more likely to just end the conversation, be like, okay, I got as far as I could. But apparently it writes pretty high quality code.
Mhm.
So
And I
there's
think
like
it's
different,
changed
yeah.
in this latest version that they released 3 days ago, 4 days ago.
Yeah.
So
Okay. All right. So maybe it's
yeah,
gotten better.
things are
Yeah.
changing like, yeah, every hour basically.
Yeah.
So
It's a little bit annoying that they didn't change the number. So it's like I'm trying to talk about Gemini 2.5 Pro. If they called it 2.6 or 2.5.1,
yeah,
maybe people would have a better reference point. But yeah, um, yeah. I mean, it is like definitely it's a little bit like trying to build on quicksand, because it's like the only thing that is for sure is that all of our assumptions are going to be somewhat different in the next
Mhm.
several months.
Right. But that's a cool thing though about having those evals, right? Like we can quickly assess, oh, there's this new model. Like, when Claude 4 came out, right? Like we were like, okay, like, are we ready to roll this out? Great. Let's run the
Yeah.
evals. Let's see, like, does
Right.
it perform the same, better, worse than what changes do we need to make to the prompt in order to, to have a good quality experience. So, um,
Yeah, well, so let's talk about one aspect of that recently that I know Agus worked on, which was, so evals sort of depend on what tools you have available. Like we talked about like language servers and stuff like that, and we don't just use language servers for tools, but also we use them for providing diagnostics and things like that, like telling the model like, oh, there was an error in this file or this or that, and that's part of what it uses in its loop to figure out like, is my code working yet? And one of the things that those in turn rely on is, it's like, okay, if you want to have diagnostics for, let's say, Node.js, it's like, okay, what version of Node.js do you have installed locally? And so now if you run the evals and it's just using whatever version of Node.js you have on your system, all three of us could each run the same suite of evals on the same checkout of the code base, but get different answers, not just because of the variability of the models, but because maybe we just have different versions of like what the model's using locally. And then of course, like, there's some obvious like, oh, containers, like, why don't you just problem solved, right? But as August discovered, it's not as simple as that.
Yeah, I mean, I guess ideally we will run everything in containers, and I think we probably should still try to in the future. The main issue right now is that most of our evals were Rust based, and Rust likes to create these like humongous target directories and like use a lot of resources. So you have to like set your VM settings like super high for it to work at all. Uh, and yeah, at the moment we're trying to run all these evals locally, and it was kind of problematic to run them in a container. Um, so yeah, at some point we reduced that examples a lot and trying to find like some really useful ones that we wanted to focus on, and drive our development around that. So yeah,
yeah.
that's yeah.
The use of containers, though, to me is still interesting. Like, I'm really excited about Dagger, for example. Like,
Right.
just having this idea of like, okay, like we can take, we can create a container that's like parked in the exact, in the perfect position to run an eval on, right? And then like now we can run 100 of those, right, in parallel and on, different machines.
somewhere. Yeah.
Yeah,
Right.
I think that's a really cool thing, and not only for evals, I think it will be interesting to experiment with that with like the agent too, right? Like, and that's something that they I think they released this recently. What's called container use.
Mhm.
They announced it recently at the AI fair. I think that's super interesting. Just having like a container where like you can run the agent on, and you can sort of like have it go off in a totally different direction, and like having some orchestrator again, like in your local Zed instance, where you can look at the diff, like merge different agents outputs. That's I don't know, that in terms
Mhm.
of the future, that's something that's really really exciting to me.
Yeah, and
Yeah, I
to
also
be
think
able to
there's
resume from any point after you've started it too is super cool.
oh,
I
that
think.
too. Yeah.
Yeah.
Right, like restore a checkpoint, not just in terms of like local file system state, but in terms of like other pieces of state that aren't necessarily from the local file system. Yeah, that's true. And then also
Exactly.
there's the security aspect, because like one of the things that people are concerned about is like, okay, can my agent read my like .env with all my secrets in it, and then can it like potentially send those off somewhere that I don't want them being
Right.
sent off, or even I don't even want them being sent to whatever the API provider is. And yeah, like on your local file system, we have to do like a number of tricks and stuff like that. To it's like, okay, well, when it reads stuff, like when the agent reads stuff from your project, we don't give it access to things that are in your hidden files list. But if it runs a terminal command, all bets are off, and so you have to give it permission. It would be much nicer if you could just set it up with a sandboxed environment where, like in that container, it can't even see your .env, and so it can.
Mhm.
You don't even need to prompt for like the terminal use. It's just like, yeah, no, like we already pre gave it access only to the things that you wanted it to have access to, so it can just go and do whatever it wants, and it's not going to mess up your file system or anything like that. It seems like if we can get that working, it really would improve a lot of the UX like sharp edges that we have to deal with right now.
100%.
Nice. Okay, so we've talked a lot about like some of the challenges of like getting to this point. Why don't we talk a little bit about some of the like potential future directions? We're already kind of getting into that a little bit with like we've talked at kind of like a general level about like orchestration of agents. We talked a little bit about like containers. What are some of the like most exciting to you guys like potential future things that we could do with what we've got?
Yeah, one thing that's exciting to me, and it's gonna depend a lot on hardware, like local hardware, is like running models locally more. Like I think that's still like a very interesting development that I think is obviously the big labs will always be on the frontier, but like just the ability of like, I don't know, I was looking at the benchmarks from Quen 3, right, where they have like this mixture of experts model that like is only 30B. No, I think it's 3 billion active parameters, but like it's a 30 billion parameter model. And that has like great performance apparently, and so just the ability of like running that locally, that sounds pretty cool. Being able to use an LLM on a plane, uh, right? Like you can do that now, but like I think these model, like the sort of open weights version of these models, like are kind of getting to kind of catching up with the frontier, and that's something I'm really excited about. Even in Zed, like again, with our philosopher, like bring your own API key, but also run your model locally. Use Olama. That's great. Do that.
Right.
So that's something I'm really like excited to explore and like keep investing on.
Yeah, I mean, it's cool that you already can do that, but yeah, it's like in a future where you have like where it's more common to have the intersection of like models and hardware, that it's like totally feasible to run maybe even all of this locally on your machine. That could be so great, like that maybe we make that more of a first class thing, so it's not like today, in order to run it on Olama, you have to like
Right.
select Olama from the drop down, you have to have separately Olama running, and like maybe we could just bake that all in, so it's just like
Right.
well, when I first started working on this stuff, I naively, not realizing that we were not there in terms of hardware and models yet. I was like, oh, why don't we just offer a default out the box? We run the model locally so that you don't have to sign up for anything. You can just try it out. And I was like, oh, because it's complete garbage. That's stupid. No one would try that out and be like, oh, I want to like try out the more serious version of this. This is terrible. But having said that, I mean, yeah, like the trend certainly has been that models keep getting better and hardware keeps getting faster and cheaper. And if both of those trends continue for long enough, eventually you get to the point where it's like, yeah, you can have a totally normal experience, like reasonable offline air gapped, everything like all on your machine. And at that point, yeah, why wouldn't we just make that a default out the box thing that
Right.
you don't have to install anything. You just download Zed and just like, cool, here we go. AI agents
Yeah.
run.
Something else I've been thinking about, which I think, right now, like the experience is already pretty cool, but like, and these models are going to get better. We don't know like how better they're going to get. Maybe like we're on a path to AGI, but even if we aren't, like, imagine what you could do if like the amount of tokens that are being output becomes a lot faster, right? Like,
Yeah.
right now, like it takes a while to sort of like, go from the start of a conversation to like a diff that you can see. But like, what if that takes 5 seconds? Like, to me, that's like super interesting. Like now all of a sudden you can explore a lot faster, right? And like,
Yeah.
granted, you still need to review the code. But being able to generate it super fast, I think it also changes some of these like UX considerations, right? We worked on streaming edits. Maybe that won't matter because like it's gonna be so fast to output the code that like you just see it in the blink of an eye. So
Right, like
that's
following
something.
the agent is nauseating. Yeah.
Right.
So yeah, I think we'll need to like find different UXs for that as well, right? Like what does that look like in a world where like you can generate a ton of code like almost instantaneously?
I think also if you can do that, it creates an incentive to be able to like have it explore multiple paths, and then maybe having some way to like eval each of them automatically and pick the best one. I don't know. There's a lot of exploration there, I think.
I think orchestration, kind of this sub-agent world and like kind of this orchestration thing we've been talking about is something we're going to be focusing on, and like that I'm really, really excited about. So excited to do another Zed Decoded at some point where we talk about how great that experience will be in Zed.
Yeah, I mean, one thing that's wild, we were chatting a little bit about this like before we started talking, is just like, unlike a lot of the other features in Zed, this one, it's been a lot. I mean, as you heard, like this is a really bumpy road to get to the point where we are, and yet there's still a long way to go. It's not like, like some other features we feel like, yeah, it took a lot of work and then we nailed it and now it's good. It's like, no, this is like, it took a lot of iteration just to find, like, to get to where we are now, and we're still looking down the road, and it stretches so far into the distance we can't even see the end of that road yet.
Right. Yeah.
So there's a
Yeah.
lot of progress has been made, but also there's still a ton of room for improvement and like ways to make this experience like much better.
100%.
Yeah. Well, I'm excited to see that future because we're all going to be a part of building it. So yeah, hopefully people enjoyed this deep dive into how we got where we are with the agent panel, and thank you guys both for chatting with me about it.
Thank you for being such a great host.
Awesome.
Yeah, thanks, Richard.